Welcome to the session for Gd&T for Design and Quality Engineers. In this session, we are going to see the introduction of Gd&T and advantages of Gd&T in drawings. Gd&T is a technical drawing language which is used as a standard throughout the world. In the manufacturing environment, quality is very important and we must control the cost and process must minimize waste and use the resource very effectively. To achieve these things, many parts are now purchased globally. No component like all the companies need not have to be manufactured in the same organization or in the same machine shop. If a similar part is being supplied by a supplier for a less price outside the country or outside the company, so companies are ready to go and purchase those parts in order to buy all these parts outside our company. So we need to make sure that the design intent needs to be conveyed properly to the manufacturing plant or the supplier, like what we need that needs to be supplied informed to the supplier. So when we use Gd&T, since it is a precise language with engineering symbols, these symbols can be understood by all the people in the world. So if we create a drawing using these symbols, this will be easily readable and it will be interpreted in the proper manner by whoever is reading the drawing in the world. So this gives us the benefit of conveying the design intent properly to the manufacturing plant, so that the manufacturer creates the component in such a way that it is functionally fit and it meets our standard and it satisfies our assembly also. So Gd&T is widely used in aviation industry, automobile industry and heavy equipment industry. Further, what is Gd&T? So geometric dimensioning and tolerancing is a language of symbols, as we discussed earlier, used to describe the paths, nominal geometry and the allowable tolerance for variation. It defines your component's geometry and it gives a tolerance also. How much it can vary, because no feature without any tolerance you can't manufacture any component. So we need a tolerance so that can be defined properly using a Gd&T. It helps us to define a feature's location, shape and orientation of size. So you can see in this figure, you can see size, form, location and orientation. These can be controlled effectively by using Gd&T. So this is very important for any component to be manufactured. The main advantage, like a function of a part and how that part functions with related parts, is taken into account when we use Gd&T. If you don't use Gd&T, a part will be dimensioned only based on its own features, like a component is having a hole, means only hole that much only it will be there. But when we use Gd&T, it considers this part, where it is going to assemble or what is the function of this part, and accordingly what are the tolerances required, those things will be taken into account and it will be applied. So Gd&T has established standard which is used throughout the world, so everyone can follow it very easily. The proper application of Gd&T is defined within American Society of Mechanical Engineers, standard used primarily in the United States. So this is the standard which is followed in the United States American Society for Mechanical Engineers. They have described that Gd&T, how to use the Gd&T in a drawing. This is followed in US. In the rest of the world, it is defined by the International Organization for Standardization, which is called as ISO. So expect the US remaining part of world are following these one, including India. Further, types of dimensions. There are two types of dimension. First of all, unilateral tolerance. If the tolerance is allowed on one side of the basic size, it is called as unilateral tolerance. Example, if a dimension is given as 50 mm plus 0.1 mm and minus 0.1 mm, it means the actual dimension can vary between 15 mm and 50.1 mm but cannot be less than 50 mm. Second type, bilateral tolerance. If the tolerance is allowed on both sides of the basic size, it is called bilateral tolerance. For example, a dimension specified as 50 mm plus minus 0.1 mm means the actual dimension can vary between 49.9 mm and 50.1 mm. Thank you.